Welcome students. Today we will solve 12th problem on trusses and we will solve this through method of sections. So let us start the lecture. We are given one truss over here and we are asked to find the forces in members BC, GC and GF of this truss by method of sections. We know whenever we have to solve any problem of trusses through method of sections, we have to first identify the types of supports given in the truss and we have to label the reactions provided by those supports. But in this truss, supports are not shown directly, reactions are placed at joint A and at joint E. So at joint A, we are shown one reaction in our direction and it is labeled as RAY, and at joint E, reaction REY is labeled in our direction. So the next step is we have to find these two reactions first through equations of equilibrium. So let us find RAY and REY through equations of equilibrium. So let us apply the first equation, that is summation Fy equal to 0. So over here in this truss, no force is acting along x direction. So that is why Fx is not considered. So directly we are applying summation Fy equal to 0. So how many forces are acting in y direction? There are 5 forces. RAY and REY, these two are acting in our direction, so we'll consider these two as positive forces. While 8 kN acting at joint B, 6 kN acting at joint G and 12 kN acting at joint F. These three are acting in downward direction, so we have to consider these three negative. It means equation will be RAY plus REY minus 8 minus 6 minus 12 equal to 0. So from here we will get one equation, RAY plus REY equal to 26. So in this equation we have two unknowns, we cannot solve it, so let us call this equation as equation number 1 for time being. Now we will apply the next equation of equilibrium, that is summation m equal to 0. Let us consider moment about joint A. So moment because of RAY will be 0 because it is intersecting moment center. So we have to consider moments because of other 4 forces. So let us discuss the moments because of these 4 forces about joint A. Let us start with this reaction. REY will generate anti-clockwise moment, so that will be positive moment. And its perpendicular distance from moment center is 6 meters. It means its moment about joint A will be REY into 6. Now let us discuss moment because of 12 kN force about joint A. This force will generate clockwise moment, so we have to consider that moment negative, and its magnitude will be 12 into 4. Now let us discuss moment because of 6 kN force about joint A. 6 kN force will also generate a clockwise moment, so we have to consider that negative, and its magnitude will be 6 into 2. Now let us consider moment because of 8 kN force acting at joint B. Now this will also generate clockwise moment, so that will be again a negative moment. Now let us find its magnitude. In order to find its magnitude, we need its perpendicular distance from joint A. So let us first sketch its line of action. So let us say this is line of action and it intersects member AG at a point, let us say that point is X. So the perpendicular distance between the line of action of 8 kN force and moment center will be this distance, that is AX. So it means if we have to find moment because of 8 kN force, first of all we have to find this distance AX. So let us see how we can find this distance AX. In this truss we are given only 3 dimensions, AG, GF, FE. Apart from these 3 dimensions, no other dimensions are given to us. Now if we want to find AX, then we have to work on this triangle ABG. In this triangle, we know these two angles, 30 degree, 60 degree. It means this angle will be 90 degrees. So triangle ABG is a right angle triangle. And in this right angle triangle, we know this angle, we know this hypotenuse. It means we can find this perpendicular BG. So we can say in triangle ABG, sine 30 is equal to BG upon hypotenuse. Then we will get value of BG. Once we get value of BG, then we will make use of this triangle BXG and we will find this base XG through cos formula. We will say cos 60 is equal to XG divided by BG. So BG we have already calculated from triangle ABG. So we can get value of xg. So once we get value of xg, we can subtract that value from 2 meters, then we will get ax. So let us start with this triangle ABG. So we will say in triangle ABG, sine 30 will be equal to perpendicular BG upon hypotenuse 2. So BG upon 2. From here we will get value of BG as 1 meter. Now we will say in triangle BXG, cos 60, that will be equal to xg divided by bg. Bg we already know equal to 1 meter. So from here we will get value of xg as 0.5 meters. So this is 0.5 meters. It means now ax will be equal to 2 minus 0.5 equal to 1.5 meters. So we got ax. So moment because of 8 kilonewton force about joint A will be equal to minus 8 into 1.5. It means this equation will be equal to Rey into 6 minus 12 into 4 minus 6 into 2 minus 8 into 1.5 equal to 0. So from here we will get value of Rey and we got positive answer. That means the direction labeled in the question is correct. There is no need to reverse that direction. Once we get value of Rey, we can find value of Rey through equation 1. So we will say put value of Rey in equation 1 and we will get value of Rey as 14 kilonewtons. And this is also a positive value. That means the direction given in the question for Rey is correct. Now before finding the forces in these three members, let us first find another important length, that is Bx, because this we will need in the calculations of these forces. So for that we will say in triangle BXG, sine 60, that means perpendicular upon hypotenuse. So sine 60 will be equal to Bx divided by Bg. Bg we have already calculated as 1 meter. So from here we will get Bx as 0.866 meters. So this length will be helpful for next calculations. So we have found Bx as 0.866 meters. Now in the next step, we will label the reactions calculated by us. So we have calculated Rey as 12 kilonewton and Ray as 14 kilonewton. Now we'll find the forces in members BC, GC and GF of this truss. So let us see where are these three members. Member BC is over here. This is member GC and this is member GF. Now we have to decide a section in order to cut this truss, and we know we have to cut this truss in such a way that section must cut at the most 3 members of the truss, and those cut members must include the members of the truss for which we have to find the forces. Now you can see we have to find forces for 3 members BC, GC and GF. It means we have to cut this truss along this section, because If we will cut along this section, then we will be able to satisfy both the conditions. That section must cut at the most 3 members of the truss, and those cut members must include the members for which we have to find the forces. Now we have cut the truss into 2 parts. So this is left section of the truss and this is right section of the truss. So for the next step, we have to consider any of these 2 sections. So let us consider left section of this truss. So we will say equilibrium of left section of the truss, and we will draw the free body of left section of this truss. So in order to draw the free body of left section of this truss, we have to show these 3 members. Then we have to show this reaction and external force at joint B, external force at joint G. Then we have to show these 3 cut members. So let us draw the free body of left section of this truss. So we have shown 3 members and we have labeled reaction at joint A, 8 kN external force at joint B, then 6 kN external force at joint G. Now we will show these cut members also, BC, GC and GF. So let us show over here. This is member BC, this is GF and this is GC. Now in the next step we will label forces in these 3 cut members, and we will label these 3 forces tensile forces. This is member BC, so we have labeled force FBC away from the joint, that is tensile force. This is member GC, and in this member we have labeled its force as FGC and we have labeled it away from the joint, that is tensile nature. This is member GF, and in this member we have labeled its force as FGF and we have labeled it away from the joint because we have to consider it as tensile. Now after this we will see, is there any inclined force acting in this free body? Yes, there are 2 inclined forces acting in this free body. It means in the next step we have to resolve these 2 forces into their components. So let us start with this inclined force first. So this force is acting at this joint. So from this joint we will draw 2 lines, one along horizontal direction and one along vertical direction. So these 2 are representing 2 components of this force. So let us label the direction of these 2 components. For that we have to see the direction of force first. Force is acting away from the joint. So in these 2 members also we will represent their direction away from the joint. After that we will find the magnitudes of these 2 components. Before that we have to locate angle of this force with any of these 2 components. So let us locate its angle with the horizontal component, means this angle. And this angle is equal to this angle, corresponding angles. So that angle is 30 degrees. It means this angle is 30 degrees. And we are considering angle of this force with this component. So this is a cos component, other component will be sine component. It means magnitude of this force will be FBC cos 30 and that will be FBC sine 30. So we have labeled the components of this force. Now it's time to resolve the other force, that is FGC, into its rectangular components. So this is the origin of this force. So from this origin we will start 2 lines, one in horizontal direction and one along vertical direction. So these 2 are representing 2 components of this force. Now let us represent the direction of these 2 components. For that we have to see the direction of force first. Force is acting away from the joint. So in these 2 components also we will show direction away from the joint. Then after that we have to locate angle of this force with any of these 2 components. So let us locate the angle of this force with the horizontal component. and that angle is given over here as 60 degrees. So this angle is 60 degrees. We are considering angle of this force with this component, so this is cos component, this is sine component. So magnitude of this component will be FGC cos 60 and this component will be FGC sine 60. Now we are ready with the free body of left section of this truss. Now we can apply equations of equilibrium to find the unknowns. So let us start with the first equation, that is summation Fx is equal to 0. So how many forces are acting in x direction in this particular free body? There are three forces. First is FGF, then FGC cos 60, then we have FBC cos 30. So these three forces are acting along x direction and these are acting towards right. So we will consider these three positive. So equation will be FBC cos 30 plus FGC cos 60 plus FGF equal to 0. Now in this equation we have three unknowns, we cannot solve it. So let us call this equation as equation 1 for time being. Now let us apply the second equation, that is summation Fy equal to 0. So let us see how many forces are acting in y direction. First is 14 kilonewton acting in upward direction, so we will consider this as positive. Then we have FBC sine 30 acting in upward direction, we will consider this as positive. Then we have 8 kilonewton acting at joint B in downward direction, we will consider this as negative. Then we have FGC sine 60 acting in upward direction, we have to consider this as positive. Then we have 6 kilonewton force acting in downward direction, then we have to consider this as negative. So final equation will be FBC sine 30 plus FGC sine 60 minus 8 minus 6 plus 14 equal to 0. So from here we will get second equation as FBC sine 30 plus FGC sine 60 equal to 0. So this equation also has two unknowns, we cannot solve it, so let us call this equation as equation number 2. Now let us apply the third equation, that is summation m equal to 0. So over here we have to observe a very important point, that at which joint of this section we should apply the moment so that we should get the value of unknown forces. Now we have to find three unknown forces, FBC, FGC and FGF. FGC and FGF are acting at joint G. So if we will consider moment about joint G, then moment because of FGC and FGF will be equal to 0 because these two are intersecting joint G. So that equation will have only one unknown and we can solve that unknown easily. So we will consider moment about joint G. So we have to consider moment about joint G, then we have to talk about moments because of four forces, FBC cos 30, FBC sine 30, 8 kilonewton and 14 kilonewton. Let us first observe the moment because of 14 kilonewton about joint G. It will generate a clockwise moment and we have to consider that as negative, and its magnitude will be 14 into this distance, which is 2 meters over here. Now let us observe moment because of 8 kilonewton force about joint G. This force will generate anti-clockwise movement, so we have to consider that as positive, and its magnitude will be 8 into xg, and we have calculated value of xg as 0.5. So its magnitude will be positive 8 into xg, that is 0.5. Now let us observe moment because of FBC sine 30 about joint G. It will generate a clockwise moment, so it will be negative moment and its magnitude will be minus FBC sine 30 into xg, that is 0.5. Then we will observe moment because of this component FBC cos 30 about joint G. It will generate a clockwise movement, so we have to consider this as negative. Its magnitude will be minus FBC cos 30 into Bx, this distance, this is 0.866. We have calculated it in previous steps. So equation will be minus 14 into 2 minus FBC sine 30 into 0.5 minus FBC cos 30 into 0.866 plus 8 into 0.5 equal to 0. So from here we will get value of FBC as minus 24 kilonewton. And we got negative sign over here, that means FBC is a compressive force. So now we will say put value of FBC in equation 2, then we will get value of FGC as 13.85 kilonewtons. It is a positive value, so it means FGC is a tensile force. So once we get value of FBC and FGC, we will say put these values in equation 1, then we will get value of FGF as minus 13.85 kilonewtons. So we got negative sign for it, so it is a compressive force. So we have found the forces in these three members of the truss. So I hope this answer is clear to you. Thank you very much.